Hi children, how are you? My name is Sridevi. Due to pandemic condition, schools are unable to reopening. That's why we conduct the online classes for you. You 10th class students, don't waste your time. You will use the time properly for your preparation of examination. Today we are discussed about heat lesson. Already you completed heat lesson in your schools, but we briefly discussed all points of the heat chapter. Let us start the session. First of all, what is meant by heat? Heat is a form of energy. It can transist. Heat is a form of energy. It can transist. Heat can transfer from hotter body to cold body. Heat transfer hot body to cold body. To prove this statement, we do one experiment, simple and easy experiment. Take one beaker, fill it with beaker with hot water, put the thermometer in hot water. What do you observe? Gradually, the mercury levels increases in the thermometer because of water is hot, thermometer is cold. Here, water transforms the heat energy to thermometer. That's why the mercury level in thermometer is gradually increases. Now put the thermometer in cold water. Now put the thermometer in cold water. What do you observe? Thermometer reading is gradually decreases because of water is cold here. Thermometer is hot. Heat is transformed hotter body to colder body. That's why here thermometer transform the heat energy to water, because that's why here thermometer reading is gradually decreases. Thermometer reading is gradually decreases. Now we learn about temperature. There is a small difference between heat and temperature. There is a small difference between heat and temperature. Temperature means the degree of hotness or coldness. The degree of hotness is coldness is called as a temperature. The degree of comparison of whether it is hotness or coldness is known as temperature. Temperature is depends upon heat. Temperature is depends upon heat. Temperature and heat are measured in units. The units of temperature and heat is units of heat. Heat is measured in SI unit, joules. Celsius units of heat is calorie. 1 calorie is equal to 4.186 joule. 1 calorie is equal to 4.186 joules. Like that, temperature is measured in SI units by Kelvin and also measured in degree centigrade also. 0 degree centigrade is equal to 273 kelvins. 0 degree centigrade is equal to 273 kelvins. Here is the chance to ask a question in public examination for you. Like that, you concentrate on this topic. Here, SI unit is measured in Kelvin. Kelvin is also convert to degrees. Degrees is also converts to Kelvin. Here is the chance to asking question by change the temperature in kelvins to degrees, degrees to kelvins, kelvins to degrees. Next we topic absolute temperature. Absolute temperature. The temperature is measured in Kelvin scale is known as absolute temperature. Temperature is measured in Kelvin scale is called as absolute temperature. Next we learn about kinetic energy and temperature. Kinetic energy and temperature. Kinetic energy and temperature. First of all, we know what is meant by kinetic energy. Kinetic energy means a body in motion, it attains kinetic energy. A body in motion, it attains kinetic energy. Kinetic energy is directly proportional to temperature. Kinetic energy is directly proportional to temperature. To prove this derivation, we can do a small daily life experiment. Take two beakers. Take two beakers. Name it A beaker and B beaker. Take hot water in A beaker. Take cold water in B beaker. Take some food granules or food color packet. Put some granules on A beaker and also at the time in B beaker. Put some granules in also B beaker. Do you observe which beaker is motion of particle is more? You are right. In hot water, the granules of food color is faster when compared to B beaker. That is, heat water traveling of particles shown clearly and fastly. In cold water beaker, motion is of a particle is slow when compared to A beaker. This is the proof that kinetic energy is directly proportional to temperature. If temperature increases, kinetic energy also increases. Kinetic energy increases, temperature is also increases. Kinetic energy is directly proportional to temperature. Next we learn about specific heat. Let us observe specific heat. Can you discuss about specific heat? First of all, what is meant by specific heat? Specific heat means the amount of energy required to certain mass of a substance. Certain mass of a substance. To understand this concept, we will take one simple another experiment. Take one big beaker, fill it with water with half of the beaker. Fill the beaker with half of water. Take two test tubes with one holded rubber corks. Two test tubes with one holded rubber corks. Close the test tubes with one holded rubber corks by putting thermometer into it. These test tubes are fitted by the retard stand as shown in the figure. In first test tube, we will take coconut oil. In second test tube, we will take water. In the test tube, one test tube, we take oil. Another test tube, we take water. Gradually, for this activity, due to heat to this beaker, what do you observe? After some time, gradually increases the water temperature and also gradually increases oil temperature and also water temperature. For 50 degrees centigrade, I will tell 50 degrees centigrade for understanding of your purpose, or otherwise you will take 60 degrees or 20 degrees. Wherever it is, you take for 50 degrees centigrade. Which time, how much time will be taken for 50 degrees centigrade? One clean observation is there. Here oil is 50 degrees. Oil is attains 50 degrees, then water fastly. Oil is attain 50 degrees, then water. Here we observe one point. Oil is absorb heat more than water. Here one point is we conclude the substance differ specific heats. Here oil has one type of specific heat, water has one type of specific heat. The specific heat value is differ from one substance to other substance. Let us do derivation for specific heat. To understand the derivation, you can do one small activity. Take one beaker. Take 100 grams of water in the beaker. Take another beaker. Pour 1000 grams of water in that beaker. In first beaker, we take 100 grams of water. In second beaker, we take 1000 grams of water. When compared to quantity, this is the less than this beaker. Compare this both beakers. This is less mass. This is higher mass. Okay. Now we put the heat for 2 beakers. Put heat for 2 beakers. Okay, children. Which beaker fastly heated? You are right. This beaker get fastly heated. This beaker get fastly than this beaker. Why? Mass is less, so that is why heat is absorbed fastly. That is, Q is directly proportional to M. Heat is directly proportional to M. Mass is less. Heat is less. Mass is low. Heat is also low. Here we conclude one point from this experiment. Q is directly proportional to M. Another experiment. From this experiment, we learn Q is directly proportional to M. This is first equation. This is first equation. Take another simple experiment. Take one beaker. Put the water in half of the beaker. Observe the thermometer reading every 2 minutes. What do you notice? Temperature is gradually increases with the time. Temperature gradually increases with the time of temperature. That means Q is directly proportional to time. Q is directly proportional to time. Here Q is directly proportional to delta T. This is a second equation. From 1 and 2 equation, we observe heat is directly proportional to mass. Heat is directly proportional to temperature. Heat is directly proportional to mass and time. From 2 equations, we write like this. From 2 equations, we write like this. Q is directly proportional to M. This is first equation. Q is directly proportional to delta T. This is second equation. From these 2 equations, we can write like this. Q is here S is constant. That means specific heat. S is a constant. It denotes specific heat. Here we derived a specific heat. S is equal to Q by M delta T. S is equal to Q by M delta T. This is the... Okay children, let us observe simple and easy daily life activity which are related to our heat chapter. Okay, first of all, take one candle, put it with fire, put fire for candle. Put hands like this. Put hands like this. What do you observe? After 1 or 2 minutes, we feel heat to our hands because of here candle is hot, our hands is cold. That's why here candle is hot body, our hands is cold body. We know heat is a form of energy. It can transfer hot body to cold body. Here from candle to our hands, heat is transformed. Take another activity to related to heat. Take one ice cube. Take one ice cube. Put ice cube on your hands. Here hand is a heat body. Ice cube is a cold body. Here heat is transformed to hand to ice cube. So ice cube starts melting. These both 2 experiments are related to heat. From these two experiments, we can identify heat is a form of energy. It can transform hot body to cold body. It can transform hot body to cold body. Okay, take another and simple experiment. Take spoon, 2 spoons, which one is made up of with metal and another one is made up of with plastic. Here I will take plastic. You also take take 2 spoons. One is made up of with metal spoon, another one is made up of with plastic. Here I will take plastic spoon. You also take wooden spoon also. Both 2 spoons are kept in fridge for 1 hour. Both 2 spoons are kept in fridge in 1 hour for 1 hour. Then you will observe which spoon is colder, which spoon is hotter. Yes, you are correct. Metal spoon is colder than the plastic spoon or wooden spoon. Here we can define from this experiment the temperature means the degree of comparison of two bodies, whether it is hotter body or colder body. From this activity we can easily told the degree of hotness or coldness is known as temperature. Here I will take another experiment for kinetic energy. Take 2 plastic cups or glass cups. Take hot water in 1 beaker. Take cold water in another beaker. Take some food granules. Take some food granules. Put the food granules in hot water beaker and some granules in cold water beaker. Here one is observed. The motion of food color is high in hot water. The motion of granules, food color granules, motion is high in hot water when compared to cold water. When compared to cold water. In this, motion is kinetic energy is high. Motion of the particles is also high. From this experiment, we can prove kinetic energy is directly proportional to temperature. Okay children, let us do another activity for specific heat. We know what is meant by specific heat. The amount of energy required to raise the certain mass of a substance. Okay, we can observe samosa. Samosa is colder. Inside of the ingredients are hotter. Here, outside of the samosa is cold. Inside ingredients specific heat is high. Okay, let us take another activity for evaporation. Take 2 cups. Take 2 cups, which is filled with spirit. Which is filled with spirit. Take 2 bowls and filled with half of the cup with spirit. Put lid to 1 cup. 1 cup is without cup. 1 cup is without cup. 1 cup is with cup. Put these 2 cups in below the fan. Let us leave for some time, for 1 hour, not 1 hour, 4-5 hours. Leave it in one room or open area. Then you will observe these cups. What do you observe? In without lid cup, there is a no spirit. There is a no spirit. In this cup, we will observe spirit because of here lid is there. So here evaporation is not high than this because of here lid is there. That means evaporation depends on the surface of area also. Let us take another example. take one bottle, in fridge, kept in out of the fridge. After some time, for 2 or 3 minutes, you will observe small water bubbles on the bottom, on the bottle, because of here condensation is takes place. Here condensation is takes place. Observe children, here are small water bubbles. Here are small water bubbles on the bottle. This is for example for condensation. Condensation means the phase change to gaseous to liquid state. The phase changes gaseous state to liquid state. Here in gaseous state, molecules or decreases the temperature and forms in water drops. Here this is a phase that change into gaseous state to liquid. This means this is condensation. Here we observed evaporation. In this activity we observed condensation. From this activity we observed kinetic energy. From this activity we observed kinetic energy. Okay children, science is a knowledge subject. Science is a knowledge subject. Science is a knowledge subject. From doing like this activity, you developed creativity in your let us do activities in your home. From these activities, not only this, by any activity of science, you can develop interest also in your subject. And also for specific heat, I will take another more activity. So what is meant by specific heat? Specific heat is amount of required to raising certain mass of a substance. The equation for specific heat is S is equal to Q by M delta T. Here S means specific heat, Q means heat, M means mass, delta T, that is T means temperature. T means temperature. Okay, for in our daily life situation, example for specific heat is you will observe pans. These pans are used in our kitchen daily. While we are cooking, the pan was getting heated, not handle, because of the specific heat of pan is high than the specific heat of handle. These are all activities related to our heat chapter. These are simple activities. These are easily available in our kitchens. So you also try these activities, and more activities also we will try where what substances are available for you. Take and observe so many science concept. Okay children, today in our session we will learn about definitions, derivation of specific heat, some daily life activities and applications, some uses of temperature. These are all observed in our session. Okay children, evaporation is a surface phenomenon. Evaporation depends on 3 factors, that is surface area, temperature and humidity. Let us chance to giving questions in public examination. Here is the chance to giving public examination like these problems. Convert 32 degrees into Kelvin scale. Convert 32 degrees into Kelvin scale. Here is the formula to convert degrees to Kelvin. K is equal to centigrade plus 273. K is equal to 32. Here 32 degrees centigrade, 273 is equal to 232 plus 273 is equal to 305 Kelvin. This is the answer for this question. Next question, convert 315 Kelvins into centigrade scale. Here also we use this same formula for this type of problem also. K is equal to centigrade plus 273. Here centigrade, there is no given centigrade. That's why K is equal to centigrade plus 273. Here they give Kelvin value. They give Kelvin value 315. That's why we write like this. 315 is equal to centigrade plus 273. 315 is Kelvin's centigrade. There is a no centigrade value. So centigrade plus 273. We find out centigrade. That's why centigrade is equal to 315 minus 273. That is equal to, in 315 minus 273, we got 42 degrees, 42 centigrade. Here is a chance to asking questions like this also. Convert 104 Fahrenheit into centigrade scale. Here is a, for such type of questions, we use this formula. C by 15 F minus, F means Fahrenheit temperature, minus 32 by 9. Here is a Fahrenheit value. They given Fahrenheit value 104. There is a 104 value for Fahrenheit. That's why I will write F is equal to 104 Fahrenheit. Substitute F value 104 in this formula. That is C by 5. F value they given 104 minus 32 by 9 Here 104 minus 32 we get 72 by 9. 72 by 9. By the cancellation we get 8. Here is a 5. C by 5. Then 8 into 5. C is equal to 8 into 5. We get 140 degrees. Like this, you practiced so many problems. This is the chance to given problems in public examination. Compulsory, they give one problem in public examination. So, children, please concentrate on this topic and practice at your homes. This is about specific heat. Applications of specific heat. Daily, sun releases a large amount of heat to earth. Earth is mainly consist of water pot, that is oceans is mainly water source in our earth. So sun energy receives oceans and it maintains the relative thermal equilibrium to earth, that is oceans are behave like storage houses of energy. Oceans are behave like storage houses of energy. These are the applications of the specific heat. One more example for specific heat application. We are eating sometimes samosa. Samosa is cold outside of the samosa. Inside, when we are eating, inside part is hot because of ingredients of inside is more specific heat, outside is specific heat is less. And also when compared to other fruits, watermelon retains more time coldness. Another more example for specific heat, when we are cooking in kitchen, the pan will heating but handle not heating. These are all applications of the specific heat. Now we are discussed about principle of mixture method. When two thermal bodies is in thermal contact, they attains thermal equilibrium until heat will be transformed. Thermal equilibrium means heat, equilibrium means same. To attain same temperature, heat will transform to hot body to cold body. Till same temperature and both attains same temperature up to heat transform to hot body to cold body. This is the thermal equilibrium. Thermal equilibrium means to attain same temperature. Here is the chance to asking question in public examination. Question like this. One object is 20 degrees, other object is 30 degrees. What is the final temperature of these objects? While they are in thermal contact, heat transforms hot body to cold body. That is why here both attains same temperature. The highest temperature is 30 degrees. So they attains 30 degree centigrade. The answer will be 30 degree centigrade. Like this, chance to asking questions in the public examination. Children, note down the key points while teaching the lesson. You write down the running notes. And another example also is there to asking questions like that. A and B and C, three bodies are there. A body, B body, C body. They are in thermal contact. One is 10 degree, another one is 20 degree. Third body, that means C body, is 30 degrees. What is the final temperature? Answer is 30 degrees. Like these questions are arising in the examination. Don't fear. Think sometime you remember the lesson and write the answer carefully. While writing in exam, you observe question number also. It is main thing. I observed in my students, there is a not remember the question number. Blindly they write answer, but not question number. Do not do like that. Remember the question number, put the question number, answer right. Okay, next of all we learn about principle of mixture method. When two bodies are in thermal contact, one body automatically lost the heat energy. One body automatically gain the heat energy. The net loss of heat energy is equal to gain of heat energy. The net loss of heat energy is equal to the net gain of heat energy. This is principal method of mixtures. This is the principal method of mixtures. Okay, Nana. Today we are discussed another more topic, that is evaporation. Evaporation. What is meant by evaporation? Evaporation is a cooling process. Evaporation is a cooling process. Evaporation means you already heard evaporation familiar. When take two bowls. One is with spirit, another one is also with the spirit. But one bowl with lid, one bowl without lid. Both bowls are put under the fan. What do you observe after 2 or 3 hours? We observed spirit in the spirit without bowl is no more, but spirit is therein with lid bowl. Here evaporation is more occurs in the open bowl. Evaporation is fast in open bowl. Evaporation is less in closed bowl. Here evaporation is a phase. It changes liquid phase to gaseous phase. Evaporation is a phase change. It changes to liquid to a gaseous phase. It is a temperature decreasing process. Temperature decreases process. Another one is condensation. It is reverse to evaporation. Reverse to evaporation is condensation. In condensation process, phase change to gaseous to liquid. Phase changes to gaseous to liquid. For condensation, one simple example is there. In a fridge, water bottle is there. Put the water bottle inside of the fridge and put the outside of the fridge or our surroundings. What do you observe? Small water bubbles are on the bottle. This is due to condensation. This is due to condensation. Condensation is the warming process. Condensation is the warming process. Okay, Nana. Today we are discussed about so many concepts. Let us recall them first. Heat definition, temperature definition, kinetic energy is directly proportional to temperature, and specific heat definition and specific heat derivation, that is S is equal to Q by M delta T. Here S means specific heat, M means mass, delta T means temperature. Here is the chance to asking questions on the specific heat problems. Okay, then we are learn about applications of the specific heat and evaporation and condensation. All of these points are in heat chapter. Let us these points all of our recall, and once again you will read the textbook thoroughly because of our exam pattern is CCE model. Because of our exam pattern is CCE model. Question may be gives in daily life application or problem or experiment like that. Okay, you may note down the important key points while I am teaching. Okay, I will give to homework for you, that is home task. Define temperature. What is its units? Define temperature. What is it? Units. Define heat. What is it? Temperature. That means difference between temperature and heat. Next, what is meant by specific heat? What is meant by specific heat? Next question, derive the specific heat equation. Derive specific heat equation. That means S is equal to Q by M delta T. Next, write what is the units of SI units of temperature. What is the SI units of temperature? Like in examination, bits also coming like this. That means half mark answers, half mark questions. Write the SI units of temperature. It may be used for half mark question also or for 1 mark question also. So you will thorough with heat chapter and write specific heat derivation and write applications of write applications of specific heat. Okay, today we are complete the heat lesson. Later we will discuss another topic in another session. Giving this opportunity, thank you to one and all. Thank you children. Thank you.